Hi guys, welcome to the lesson. Indices today, I've called it Rule 1. It's basically when we are multiplying two expressions with the same base, we add the powers. If you're not sure what I mean by that, keep watching the video. Let's crack on and get the job done. Okay, that's what we're multiplying. 3 to the power of 4, and that means 3 times 3 times 3 times 3, 4 of them in a string. We're multiplying that by 3 to the 5, which is 5 3s multiplied together in a string. Altogether, how many 3s can you see in the string? Obviously 9 of them, so that would make 3 to the power of 9. In our second example, a to the power of n would be a multiplied by itself in a string, and there'd be n of them. A to the power of m would be a string of a's, and there'd be m of them. How many altogether do you see? Add them up, n plus m of them. Meaning a to the n times a to the m equals a to the n plus m. We simply add the powers together. And note, we can only do this if the bases are the same. By base, I mean in this case a and a would be the base, they're the same. N is a power, m is a power, and we've added the powers. So the first thing to check, is the base number the same? Yes, it is. It's 3. If the base number is the same, we can add the powers. 2 plus 4 gives us 3 to the power of 6. And please note, we don't multiply the bases together. We don't say, oh, 3 times 3 makes 9. No, we keep the base as 3 and we add the powers. Are the base numbers the same? Yes, they are, because we've got a base of 5 and a base of 5. So we add the powers. Just be careful here. Although we don't have a power of 1 written here, there is unwritten a power 1. That is 5 to the power of 1. So when we add the bases, we do get 1 plus 3, which is 5 to the power of 4. Note once again, we don't multiply the bases, keep the base the same, add the powers. In example 3, the base is the same, it's a in each case. We add the powers, just be careful, negative 4 plus 7 makes 3. And finally, is there a rule here? No, there isn't, because straight away we can see that 3, the base there, and 2, the base there, they're not the same base, so there is no room. If you actually wanted to work out what the answer to this sum was, you would have to work out 3 to the negative 2 separately and then multiply it by 2 cubed. Let's apply the rule to an algebra example. Let's deal with the number at the front first, which is 2 and 4. 2 times 4 simply makes 8. Let's move on to the next term, the a term, a cubed times a squared, add the powers, a to the power of 5, and the b term, b squared times b makes b cubed. And that is our final answer. In example 2, we deal with the number at the front first. 5 times 3, that's easy, 15. The a term, a to the power of 4 times a squared, we add the powers, and the b term, b cubed times b to the negative 2, we add the powers. Just be careful, 3 and negative 2, adding the negative 2 is the same as subtracting 2, so that would be 3 subtract 2, and that would be a power of 1. We don't put the power of 1 in when we're writing it, it's just b on its own, because b on its own means b to the power of 1. Let's put all that together then in a recap. In the expression 3 to the power of 5, 3 is the base and 5 is the power. When multiplying two power expressions with the same base, we add the powers. So in this example, our answer would be 5 to the power of 6. When multiplying two algebra expressions, we deal with the number first and then each letter. 5 times 3 is 15. The a to the power of 4 times a squared is a to the power of 6. And then the b term, b cubed times b to the negative 2 is just b. And if there's anything about the video you haven't understood, just watch it back. And if you have, that's great, because that's the job done.